Good afternoon, everyone. Welcome to Radical Academy. My name is Professor Wadia Mike, and in this video, we are going to introduce to you trivial graphs in mathematics, and this is grade 10 mathematics. So if you're new to our channel, please make sure that you do subscribe to the channel so that you never miss any single update from us, because we are normally posting our videos to this channel. So if you're new to this channel, please make sure that you subscribe to our channel so that you always get our updates from us. Now, in this video, we are going to talk about two things, okay? But I'm going to actually start with the first one, which is distance time graphs, okay? Now, what do we need to know about distance time graphs? So distance time graphs, probably before I get into the details of what this is all about, I just want to actually encourage each one of us who is watching this video to, first of all, be able to understand the definitions of some of the terms that normally describes the object that are moving, okay? So this is particularly in physics, okay? For those that have done physics before, it becomes very simple and easy to just kind of relate to this topic. So when you talk about the distance, we have to know what is distance and also what are some of the quantities that are connected to distance. Okay, now in physics, this is about the motion of an object. Okay. So when you look at this, we are trying to talk about the movement of objects, more especially such as things like the car is moving and anything that you can think of that moves, and that kind of creates a motion, a movement from one point to the other point. Okay, so in motion, we have to define the following terms like what is speed, okay? Like what is speed, what is distance, okay? Sometimes this is normally confused with displacement, okay? It's confused with displacement. So when you're talking about distance, we are referring to a quantity that is a scalar quantity, okay? But we'll talk about that in a minute. And we also have, of course, time is a quantity. And then also we are looking at velocity. And also finally, we are looking at acceleration, okay? The acceleration of an object. Okay, so these are some of the terms that you need to understand under the trivial graphs, okay? And now, I just want to say that when you talk about speed, okay, speed, we are talking about the distance moved, or the change in distance with time. Okay, so this is just defined as change, the change in distance with time. And then we have something called the velocity, for example. Now, what you need to understand is that velocity is the same as speed, except that velocity is a vector quantity. So this is the same, okay? So I'm just gonna say this is same as speed, okay? So same as speed. And then the only difference that we need to note is that velocity is a vector quantity, okay? It's a vector quantity, meaning it has both size and direction. So it has got both sides, size and direction. So it can be positive. So by direction, we mean positive or negative. So you can have -2 meters per second, -3 meters per second, and so on. And the size is that the actual number of that, what velocity is all about. And now we also have to understand what is displacement. So when you're talking about displacement, is just the change in position, with direction. So that's what displacement is all about, change in position with direction. So when you're talking about displacement, is the same as distance, except that it is a vector quantity. It is a vector quantity. That is what we need to understand. Displacement is a vector quantity. Okay. Now, what are some of the things that you also need to know concerning the formulas? Okay. So about the formulas, we know that speed equals to distance over the time it takes for something to move. Okay. And then the units are just the meters per second. Okay. So meters per second, or just the meters per second. So these are the units for speed. Okay. And then velocity, the way you can find velocity is the same as the way you can find this, is the same way we find speed. So the formula for speed is the same as that for velocity. So in that case, we are saying that velocity is just displacement. Okay. We have to be more specific about velocity, because velocity is a vector quantity, and therefore the units velocity is meters per second. Okay. So units are same with speed. So make sure you do understand that the units of velocity are the same as those for speed, except that speed is only the scalar quantity. It only has the size of that motion in terms of speed, while velocity can either be positive or even negative. So let us make sure that we do understand the differences between velocity and speed while the units are the same. So from that, now we talk about acceleration. Now acceleration is just a velocity. Okay. Okay, so acceleration, which is represented by letter A, and this can be, acceleration is just a velocity, or should I say the change in velocity, which you can just say v divided by change in time. Okay. Now the units of acceleration is just meters per second squared. So these are the units for velocity. Now, how can we now be able to find all these things? The distance, the speed, as well as the velocity. So I'm going to actually give you some of the concept that you need to understand. Okay. The concept as follows. Since you're talking about graphs, so you can have a graph like this one. Okay. You can have a graph like this one, and we know that this is the x-axis, and that is the y-axis. Okay. And from 0, you can have the motion of an object starting from 0, then goes like that, then goes like this. Okay, for example. Now, we can have, let's say, on this maximum point where it makes a 10, we can have, let's say, 20 there. Okay, so on the y-axis, on the x-axis, this is time. And also on the y-axis, this is, let's say, this is a velocity, and in meters per second. Okay. Now, if you have something like down here, for example, you have something, and there somewhere there, you can have numbers like this is 2, and then this is 4. So now you can be, the most important thing before the question comes, okay, you have to look at what is in the y-axis is velocity, and what is in the x-axis is time. So meaning what you're looking at is when you have velocity and time, the question that's going to actually come is about finding the acceleration. Finding the acceleration of that. So finding the acceleration represented by A. So which we said that acceleration is equal to V minus T. So V minus T. So we are making things simple. Now what I mean by that is when we say V, we should be more specific to what we mean by that. Okay, and now what I'm gonna do is when you say acceleration should be the change in velocity divided by the change in time. Okay, so what we mean by that again is that when you say change in velocity, what we mean is that we have velocity 1 minus velocity 2 divided by time 2 minus time 1. Now, all these are just the labels that we need to understand. So the velocity 2 is normally called the final velocity. The velocity 1 is normally called the starting velocity or the initial velocity. The time t is the final velocity, final time with which the car or the object that was in motion actually reached from the point it started. Okay, and then also the time 1 is just the starting time. So from this graph now, we can simply get the acceleration of this object, which started at 0. Okay, so let's actually pay attention to that. So we have to grab the details from the graph. Okay, so you can see that the motion goes like this. It started from 0, it goes all the way up to this point. So at this point, you have to look on the side of the y-axis. What number is there? It is 20 meters per second, meaning your velocity 2 is 20 meters per second. Okay, what about the velocity 1? So the movement of this object or car started from 0, meaning 0 meters per second. So that is a starting point. Okay, so it is 0. And what about time? So for time, we have the T2, let's say T1, the starting time. So as you look along the x-axis, okay, so from this point is 0 up to this point, okay, it reaches 2. So the starting point in terms of time is 0 second, okay, 0 second. And the final time it reached when it actually moved 20 meters per second is just 2 seconds. So those are the key concepts that I need to understand. Now, the fact that I've gotten those details, then I can simply now say so now I can simply say that acceleration is going to be v2 minus v1 divided by t2 minus t1. So this is just going to be our v2 is just 20 minus our v1 started from 0, and our t2 is just 2 seconds minus our t1 is 0. So when you do the simplification, this is going to be 20 over 2, and our acceleration just going to be 10 meters per second squared. Don't forget the units of our acceleration, just meters per second squared. Okay, so those are the most important things. Now, the other concept that you must be able to understand is about finding, let's say, the total distance. Okay, so the total distance traveled by this object, or under this the total distance traveled by an object or car under this graph. So what we mean by total distance is actually to look at the shape of the graph. So you need to relate. Okay, you have to relate and map this kind of a shape that is formed. So when you look at this one, the shape is this one. Okay, then you have this kind of the shape. And let's say now this thing, let's say the distance traveled under this graph in 4 seconds. Okay, so you can just kind of say that this kind of the area. Now we know that this shape algebraically is just a shape that we all know. Okay, so a shape that we all know. So a shape that we all know. So this is just something like this. So we can see that we have a shape like that. So all we are looking for is the area of this shape. So the distance, for you to find the distance, you are looking at the shape actually formed by this kind of a graph with respective to time and also the maximum velocity travel. So, and the distance from this is 0 all the way up to this is 4. Okay, and when you look at this point, it is 2. Okay, so we have something like a parallelogram. Okay, so the area of the parallelogram is simply just the half, okay, a plus b multiplied by the height. So you have to understand what is your a, what is your b, what is your h. So the h is just the vertical distance. Okay, so the distance moved in this way. And we can see that from this graph, from 0 all the way up to 20, so this is 20. So that is our height. And then also the a is the distance between this part. Okay, this point to that point, which you can say there is a 4 there on top. So you just have to say the difference between 2 and 4. And then the b is the base. Okay, all the way from 0 there up to 4. Okay, so this simply means that what you must do, or rather understand, is once you're able to collect those numbers, so our h is 20, our a is just 4 minus 2 is just going to actually give us 2, and our b is just going to give us 4. Okay, so from there now, ladies and gentlemen, we can just plug in these numbers in the formula. Okay, so from this point now, we are saying that our area is just going to be a is half open the bracket. Our a is this part, that is your a. Okay, okay, so your a is between 2 and 4, that is your a. And the base is all the way from this 0 up to 4. So 4 minus 0, so our base is just going to be 4. So our a is just 4 minus 2, which is just 2. So our a is this part. So this is just going to be 2 plus, then our base is 4. then our height is 20. And now you start with the bracket. So this is 6, so half multiplied by 6 multiplied by 20. Okay, now from there, let me just erase this part now. And that is going to give us half. We can say divide 2 there, it's 1, 2 into 6 is just 3. So we're going to have now just 3 multiplied by 20, and our area is equal to 0.60 meters. Now remember, we are not actually finding the area, but this area is now mapped, is now concluded as, therefore the distance is equal to 60 meters. Okay, and remember the units for distance is meters. Okay, so those are the most important thing that you have to understand. So thank you so much for watching, and this is a part 1. So if you want to learn more, guys, please make sure that you do subscribe to our channel so that you can actually, get more out of just this thing that you've seen. So we have more things that we are bringing to you. So please help us to grow the channel, to grow the audience. Make sure that you do subscribe to our channel. Thank you so much, and I'll see you in the second part of this topic, where now we are going to solve actual questions about trivial graphs in mathematics paper 1. So thank you so much, and I'll see you in the next video.